Hey guys, welcome back to another episode of Tech Guides TV. You guys have been asking me to solve some of the harder questions, so here's a hard one. Leetcode 149 max points on the line. Let's read it. Given an array of points where points at index I is equal to x sub I, comma y sub I, represents a point on the xy plane. Simple enough. There's 1, 1, 2, 2, 3, 3. So max point on a line. Return the maximum number of points that lie on the same straight line. Okay. So in example one, we see that the points array includes three pairs of points, 1 comma 1, 2 comma 2, and 3 comma 3. And it's asking us to return the maximum number of points. Okay, so there are 3 points and the output's 3. All right, so every XY pair is a point. We're counting the points on the straight line, max points on a line. So what could be so hard about this? Well, I'll give you guys a few minutes to think about how you want to approach this problem, and then we'll go through another example in a moment, and then I'll show you the code in JavaScript, and then I'll walk you through the code line by line. All right, guys, so here is example 2 before you get started. Example 2, it's also a straight line, but with negative slope. The points array includes points 1 comma 1, 3 comma 2, 5 comma 3, which is not on the line, 4 comma 1, which is on the line, 2 comma 3, which is on the line, and 1 comma 4. The output is 4. So though there are 6 points, only 4 um, are on the straight line. And before you get started, take a look at the constraints, right? Points.length is going to be between 1 and 300. Points at index I.length is equal to 2. X sub I, Y sub I, they're greater than or equal to negative 10 to the fourth, less than positive 10 to the fourth, and all the points are unique. All right, guys, you can pause the video, give this a try. Hey guys, welcome back. Today we're looking at Leetcode 149, max points on a line. It's a hard question, but hopefully you got a chance to attempt it and your code works. If it doesn't, you can look at the solution here. No one really expects you to get, a difficult problem right the first time, but that's why I made this video so we can walk through line by line and make sure you understand how we got the count of the points that are on the straight line, but not the ones that are outliers, so to speak. All right, so in JavaScript, we created this max points function that max equal to 1, and it looks like there's the outer for loop with 2 inner for loops. So that's um, lines 8 all the way through line 21 is the first for loop. All right, and then, well, that's the max points function. All right, and then from line 26 to line 35 is a get slope function. And don't forget your empty line on line 36. And then from lines 37 through 43, we have the get GCD function. So if you don't know what GCD is, that stands for greatest common divisor, I believe. So it takes in A and B. If B is triple equals to 0, it returns A. Else it returns um, get GCD with arguments b comma a modulus b. So a bit of a recursive call there. And I know we're starting from the bottom up, but you're going to need greatest common divisors to solve this problem. And the modulus operator gives us the remainder of a divided by b was the remainder, and then b comma um, the remainder as a recursive call to the get GCD um, function kind of gets you the greatest common divisor. Um, so that's a bit of math you maybe have to review when you're working with, slopes and things like that, and lines, right? But it is what it is. So if you need a math refresher, definitely look up some of the Calc 1 stuff that you maybe forgot, right? The get slope function, we input x1, y1, x2, y2. We check if x1 is triple equals to x2, then we return infinity. Else, we else we let dx equals to the difference in x2 minus x1. Um, dy, same thing, but with the y coordinates. And then we let GCD equal to get GCD of dx comma dy. And it looks like we return backtick $sign. It looks like a template literal, I believe. That's what that is. Um, dx over GCD divided by dy over GCD. And that's looks like that's the slope. And where are we using that function? Well, it looks like we're calling it from line 14. We let slope equal get slope of x1, y1, x2, y2. So that's where, the return statement on line 33 is going to return that value and set it equal to slope in line 14, right? So now let's look at the max points function, right? We've worked backwards a bit. So we let max equal to 1, for loop, let I equal 0, I less than points dot length. So however long the points array is, we iterate through every point, incrementing I, const x1, y1 equal to points at index I. All right, we let slope count equal new map. Now inner for loop. So instead of I, we're using j now for let j equals I plus 1, j less than points dot length, j plus plus. Const x2 comma y2 equals points at index j. We get the slope count dot set argument slope comma slope count dot get slope or operator 0, right, plus 1. So that's um what's going on there? We gotta keep track of the parentheses, I guess. Okay, so that closes the set method. Slope count dot set. And the second for loop. For like count of slope count dot values, the max equals math.max with arguments max, comma, count plus 1. All right, remember, we're counting the number of points that are on the straight line. We're getting the slope and getting the GCD, and then we're counting the number of points in the max points function. So if it's on the line, we count it. If it's not on the line, we disregard it. All right, and then we return max, and max is, I believe, max is equal to the number of points on the line, right? So, for the straight line with 3 points, max would be 3. For a line with 4 points on it and 2 outliers, max would equal 4. And the code reaches acceptance criteria as we see here. So the points array contains 3 values, and they're all on the line. And here the points array contains 6 values, but only 4 are on the line.